I'm out of Dunkin' Donuts coffee. It's like 8:20 at nighttime. If I drink any more coffee, I'm going to be up all night peeing and, well, because I just can't sleep. So let's get through Mr. Ooh, that's really big. Mr. Key on the answer key here for the homework for ye. Now, if you haven't done this on your own, shame on you. Don't copy me. It's not going to help you for the test. Try it on your own. Now, these should be coming as, we've only done these a billion times. Opposite over hypotenuse. Adjacent over hypotenuse. Opposite over adjacent. Hypotenuse over opposite. Hypotenuse over adjacent. The cofunctions. And adjacent over opposite. We've done them a million times. Unit circle. Don't forget. 0 degrees. 90 degrees. 180 degrees. 270 degrees. Back here to 360 degrees. What are the coordinates of this point? 1, 0. What are the coordinates of this point? 0, 1. What are the coordinates of this point? -1, 0. And finally, 0, -1. On the unit circle, this is cosine, this is cosine, this is cosine, this is cosine. So if I said, where does cosine equal 0? You'd say, oh, at 90 and 270. Where does cosine equal 1? Oh, 180 and 0 or 360. Remember, this is sine, 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 sine. If I said, hey, where does sine equal 0? Oh, sine equals 0 at 0 and 180. Where does sine equal 1? 180 or 90. Where does sine equal -1? Down here. All right, let's talk about these triangles. Don't forget when we did these triangles, these are our 30, 60, 90. Don't forget we make our hypotenuses 2. 30 makes this 60. Remember, these are 45s. I don't have to do both of them. And these are square roots of 2 and square roots of 2. Hopefully that's no news. Opposite the 30, that's the tiny side, 1. And this is the square root of 3. Now you're going to use these in lieu of the hand. Or you can use the hand. It doesn't matter. So let's get started. Just because they're multiple choice doesn't mean we don't have to show work. We're going to express 235 into radians. Now remember, to convert from radians, you're going to multiply by pi over 180. All right, so I'm going to convert this to degrees. So I don't know what that is. I got to go to my calculator. What is that? 235 over 180. So 235 divided by 180. Oh, that's 47 over 36. So this is 47 pi over 36. Catching! Okay, well, this next one's a little odd. I had to go take a look at it. I don't think we've showed this to you exactly, but let me just give you the heads up. So this one's a little tricky. Let's go take a look at it. What I want to do is I want to go over to here. See this button right here? This complicated button where I find the absolute value. Pretty much everything you want's in there. And right here, do you see this second one right here? It looks like a little degrees, minutes, seconds. I know we haven't talked about this yet, so just bear with me. That's the degree, minute, second. So it's 23 degrees and 50 minutes. It's kind of like a clock. I want to convert it to radians, so I'm going to multiply by pi divided by 180. I'll press enter, gives me this. I press control enter, and it gives me 0.4159. So I took 23 degrees, 50 minutes, and I multiplied by pi over 180, and it told me it's 0.4159, round to the nearest thousandths, it's 0.416. But I don't think we've had a conversation about degrees, minutes, seconds. I got to go look. I don't think we have. I know I haven't in class yet. I got to go look to see what I haven't done yet. So I thought that was on the old curriculum. Whatever. It's not a big deal. Find the exact value of sine of 240. So don't forget, we have to find the reference angle first. Well, I'm going to say we're at 240 degrees. That means we're down in this quadrant right here. So that means it has to be negative, because I know sine is negative down here. So I say, okay, that's a 60 degree reference angle because I'm 60 degrees away from 180. So I can do it with my left hand, put down the 60 degree finger, and I get the square root of 3 over 2. So that's the answer, negative square root of 3 over 2. Now if you don't like that, you want to come over up here to the reference triangle, we can do that as well. Sine is, here's my 60-degree angle, opposite over hypotenuse, square root of 3 over 2. And I just had to remember that it's negative. Either way is fine. Anytime it ends in a 5, that means our reference angle is going to be 45 degrees. So really what I want to do is find the cotangent of 45 degrees. But I really need to figure out which quadrant I'm in. So 135, ding, 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 negative 135, there it is. Now I know all students take calculus. Tangent is positive down here, and therefore so is cotangent. So anything negative is wrong. So those are got to be wrong. So 45 degrees. Now I'm not going to do I'm going to do tangent of 45. Tangent of 45, remember that's the middle finger. Put the middle finger down. Square root of 2 over the square root of 2, that's 1. Or, so cotangent's also the square root of 2 over the square root of 2, which is just 1. And again, if you didn't like that, we can come back up to your reference triangle. Tangent is opposite over adjacent. So cotangent is adjacent over opposite. Square root of 2 over the square root of 2, which is just 1. So that's cotangent. All right, you got to remember your trig identity. This is a huge one. What is this equivalent to? Sine squared x plus cosine squared x. You have to remember, oh yeah, that's 1. So this just becomes 1 minus b squared. Well, that's the difference of perfect squares, so I'm just trying to trick you here. Do you know that's 1 plus b, 1 minus b? Kind of a tricky question. There it is. All right, let's do some simplifying. Convert everything to sines and cosines. So this is sine x times cosine x over 1 over 1 all over sine x over cosine x. Well, I know if I divide by a fraction, I'm really going to multiply by the reciprocal, right? So I'm going to multiply by cosine x over sine x. So let's see what cancels. This sine x cancels with this sine x, and it leaves me cosine squared x. There we go, kids. Now you have to show work. It's not good enough just to have answers there, kids. Not good enough. If the tangent of an angle is negative and its secant is positive, which quadrant does it terminate in? Okay, so I don't care about secant. I know that goes with cosine. So tangent is negative. Tangent is negative in the second and the fourth, right? Because all students tangent take calculus. Cosine is positive in the first and the fourth. So the big winner, fourth quadrant, kids, there it is. Now they're trying to make it look all complicated on you. Oh my gosh, this is so crazy. All this says is tangent's positive. Oh, tangent's positive here. Tangent's positive here. Oh, I want to know where, I don't know anything about cosecant, but I know that goes with, and it's the reciprocal function of sine. Sine is negative. Oh yeah, sine's negative down here and negative down here. Remember, because all students, sine is positive here. So who's the big winner? Quadrant 3, kids. All right, so I'm going to pause before I get to this thing, and we're just going to go through these graphs. All right, I want to try to find the easiest ones first. So what I'm going to do is I'm going to try to find the cosine or the sine. Ah, there's one right in the middle there. Let me blow that up. This one right here. That's the sine curve, right? Because it starts at a 0, ends at a 0. What you can't see here is this is 2 pi, right? If that's pi, this is 2 pi. So let's see, what's my amplitude? My amplitude appears to be just 1, even though I can't really tell the scale. So y equals, it's going up first, so it's sine. It's finishing one curve in 2 pi, so what? Sine of x, that's it. So let's see if I can find the cosine curve. There it is right there. There's the cosine curve. Starts at a max, ends at a max. You got a min in between. So this is y equals, since it's starting at a max to begin with, it's positive, so y equals cosine of x. Now I'm going to go to I'm going to go to these ones. This one and this one. And what I'm going to try to do is I'm going to connect the dots. So everywhere I'm going to put those dots in. So let's plot. Now that is a sine curve. It says it starts at a 0, it ends at a 0, min and max in between. Well, if that's a sine curve, then its reciprocal function is the one that rides on its hump. So this is y equals cosecant x. I come up here, and I got a 0 here. I'm going to do it all on these points. Pi, 2 pi. So I got to go here. This, I didn't use this one, and I didn't use this one. This is, there it is. That's cosine, so that means this black function must be secant x, its reciprocal function. Now I'm going to go try to find tangent and cotangent. That's this one and this one. So it's these two right here. Now if you remember correctly, tangent has its asymptotes. Here are the asymptotes for this. Tangent has its asymptotes at 90 degrees or pi over 2 and at 270. It also is the one that goes like this. Cotangent, a little bit offset. Cotangent has its asymptotes at 0 and pi, and it goes down like this. So I know this is cotangent of x, and this is y equals tangent of x. So then I think I just got the two funky ones left. That weird one and that weird one, right? And if you remember correctly, I talked about this in class. Those are going to be your inverse function. Notice this one is not going through the origin. This one is going through the origin. Because this one is going through the origin, that has to be the inverse of sine. Because remember, sine goes to the origin. Therefore, its inverse, because you just flip x and y, also has to go through the origin. And then the other weird one then must be the inverse cosine. Oops, y equals cosine negative 1 of x. All right, let's see what we got here for this next problem. I got time. So what did I tell you? I said point A is on the unit circle. That's ginormous. That's great information. It's on the unit circle. Because that's on the unit circle, this is cosine and this is sine because it's on the unit circle. If theta is an angle in standard position whose terminal ray passes through point A, what is the value of sine of theta? That's it? Well, because it's on the unit circle, sine of theta is just the y value, square root of 3 over 2. Cosine would be the other one. So sine of theta equals the square root of 3 over 2. Ah, tough question. Do you see this word explain? Explain means words, kids. If you don't use words, you're not going to get this one right. I'm going to pause so I can come back to it and give it to you in this good answer here. All right, because they told you this is the unit circle, we know the radius is 1. We also know that if we wanted to, we could simply say because it's the unit circle, we know that the y value represents sine. But what I want to do is do this. Since I know this is a unit circle, since this is a unit circle, we know that the hypotenuse is equal to 1. Therefore, Therefore, I think I forgot an or. The horizontal side of the triangle is equal to x, and the vertical side is equal to y. Now it might help to come over and say, okay, this is the horizontal, this is the vertical side, that's y, and this is x. Since cosecant of theta is equal to hypotenuse over opposite, we know that cosecant theta is equal to 1, which is the radius, all over the opposite, which is y. Boom, there you go. Problem's done. Something to that effect, kids, okay? A student attaches one end of a rope. They love these silly questions. It makes it seem so complicated. Well, so we know that this is going to be either a sine curve or a cosine curve. Oh, look, they even gave it to us as a sine curve. So we know it's going to be y equals a sine bx plus c. Well, c is actually pretty easy. It's right here. Because we're only finishing one part of this sine curve right here. So, c is 3 feet, so plus 3. And I know this is sine. Now, what are we saying here? The rope's height above the ground is between 1 and 5 feet. So its maximum, or its minimum, is going to be 1 foot. And if it ever got to its maximum up here, it would be at 5 feet. Well, 3 feet's right in the middle there, so that helps us with that. But it also gives us its amplitude. That means it's going to go up to 5 and down to 1, which means its amplitude is equal to 2. Now, if you're waving this, I guess the way this is drawn, we probably should put a negative out front. Now I just got to figure out B. Remember, B is equal to frequency. Period is equal to 2 pi over B. Now, what did it say here? The period is 4 pi. The period is 4 pi. So I'm going to say, okay, 4 pi, which is the period, is equal to 2 pi over B. Let's cross multiply. I get 2 pi equals B times 4 pi. Divide by 4 pi. Divide by 4 pi. These cancel. I end up with 2 over 4, which is 1/2. So 1/2. So there's my answer right there. All right, we're almost done. So again, let's find the midterm, the midline. The midline's right in the middle somewhere. The maximum here looks like it's up here at 8. Max. Its minimum is at 5. So we got 8 and 5. Now the difference between these two is 3. Halfway between 3 is 1.5. So that means I'd have to go up to here. This would be my midline right here. Hard to see, but my midline's C, so y equals a cosine bx plus c. My midline is C, which is going to be at, looks like 6.5. I also know my amplitude now. I'm going to go up 1.5 or down 1.5. So y equals 1.5 cosine. And now bx. B, remember B is always going to be the tricky one, kids. Always going to be the tricky one. Well, if I see here, it looks like it's going to finish its curve here. Start here and finish. Looks like it's finishing. I got a dot here at 12, so it looks like it finishes at 12. So that means it's going to finish the one full curve in 12. So my period is equal to 12, which is also equal to 2 pi over b. Cross multiply, I get 12b equals 2 pi. Divide by 12, divide by 12, and I get b is equal to pi over 6. So pi over 6. Now, if you forget this x, you're wrong. It's an equation. It has to have a y, and it has to have an x. All right, we're almost done. Let me stop. One more stop. I think we're good. Okay, so let's take a look at this graph. Clearly, it's starting at the origin. So that leads me to believe this is a sine curve. So a sine b x plus c. But it looks like it didn't quite get to the bottom part or come back up to here. So I'm only seeing how much of the curve. Well, let's see. My amplitude is up 2. And since it's going up first, this is 2. Sine. How much of the curve did I finish in 2 pi? Well, there's 2 pi. I only finished the top half. So b is the frequency. Well, I've only finished half the curve, x, sine x. And there's my midline c. So nothing. There it is. Boom. Chakalaka. Done. Right, the equation of this one. Starting at a 0, ending at a 0, ending at a 0. This is the sine curve, so y equals, it's going up first, so I know it's going up to 3 first, so my amplitude is 3, and it's going up first, so it's positive. Sine. How many full sine curves did I finish in 2 pi? There's 1, there's 2, so my frequency is 2. And I have no transformation up and down, so I don't even need a plus c on there. All right, I'm done with that one. A couple word problems. Find the height of the wall. Oh, come on. This is geometry. This is opposite. This is hypotenuse. This is adjacent. So sine of 32 degrees is equal to wall over 30. So just cross multiply, I get 30 times sine of 32 equals wall. Or wall is equal to (30 times the sine of 32). I put it back to exact. 15.897. So wall is equal to 15.897 to the nearest tenth. Wall is equal to 15.9 feet. All right. Find the angle of x. Okay, so this is opposite over adjacent. So that's tangent of x is equal to 420 over 2,000. So we're going to do the inverse tan of this. This is all drawn back to your old geometry days. We're going to do inverse tan. So we need to bring this tan over to here. Man, we haven't seen this in a while. So x is equal to tan -1 of 420 over 2,000. That's how we use that inverse tan. So x is equal to tan -1 of 420 divided by 2,000. Control enter. 11.859. 11.859 rounded, didn't save. So we'll leave it like that, I guess. So let's round to the nearest degree. So that would be x equals 12 degrees. And is this the last problem? Wow, last problem. Find the exact value of the 6 remaining. So what does this tell us? We got to find the triangle. This is tell us sine is negative. Sine is negative here. Sine is negative here. Cosine is positive. Cosine is positive here. Cosine is positive here. So the big winner is the fourth quadrant. Now, what did I give you? I gave you sine is negative 3 over 5. Negative 3, opposite over hypotenuse. And hopefully you don't need the Pythagorean theorem to find that this is 4. All right, so we know that sine is theta is equal to negative 3 over 5. So cosecant theta is negative 5 over 3. Cosine theta is equal to 4 over 5. Notice it's positive. Secant theta is 5 over 4. Tangent of theta is equal to opposite over adjacent, so negative 3 over 4. And cotangent of theta is equal to the reciprocal of that, which is negative 4 over 3. And that's it, kids. That's all she wrote. Done with the practice test. Hit subscribe, hit like, let me know what you think. And thanks for coming to the party. Goodbye, kids. Have fun storming the castle.